Good morning, neighbors. My name is Amos from Kasawo Secondary School. I have come here to present or discuss with you a question from a topic probability, question number 11, part A. So, this number says, a fair die is tossed once and what appears on the top face is recorded. Find the probability that a triangular number shows up. Members, we have to read and interpret what? The question before we find what? The solution. Here in the question, they are talking about a die. So, I've decided to illustrate my die as seen on this chalkboard. So, what is really a die? They are telling us that a die is tossed once. A die, when it is tossed on the board, I know most of you members have ever played this game. So, if a die is tossed on the board, what happens? It will fall on the board in this form. So, there will be a number on the surface, then another one in the sideways, like this side is shown as 2 and 3. So, among these numbers, which number is needed? It is the top number that surfaces. So, this is, in this case, one has surface on top. But they want those numbers that surface on top when they are triangular numbers. So, this, as we know, most of you, the dice has got 6 faces. Though, from my illustration, I've tried to elaborate that some sides can't be seen, but I've used the separated lines to show that you can observe these faces. So, I tried to draw back the picture of the dice horizontally, and I have named the faces. This dice has got 6 faces. I've named the faces. The first face having 1, the second face having 2, the third face having 3, the fourth face having 4, the fifth face having 5, and the sixth face having 6. All these numbers are shown in form of dots on these dice. So now they want that probability of triangular numbers when that surfaces on the top, when the dice is thrown on on the board, is tossed. So now, what are triangular numbers? Members, you have to ask yourself a question: do I know triangular numbers? Since previously from our primary, we learned about these numbers. There are many numbers. We have prime numbers, we have got odd numbers, we have got composite numbers, triangular numbers, square numbers. So, what are these triangular numbers? I have here some 2 formulas to use when I want to find these triangular numbers. So, my first formula will be that I will have 1 as my first triangular number. So, my first triangular number in this case will be 1. I will move on adding on this one the following counting number. So, in the second step, I'm going to add this 1 plus the second counting number, which is 2, to obtain 3 as my second triangular number. So, in the third step, I am to count 1 plus this one plus 2 plus 3. So, in this third step, the counting numbers, the first 3 counting numbers are appearing. In the second step, I'm having the first 2 counting numbers appearing. In the first step, I'm having the first counting number appearing once. So, I will obtain 6. So, in the fourth step, I will have 4 counting numbers. First, the 4 first counting numbers being added like this. To obtain, this is 10. So, if I reach here, I will first. So, when I reach here at this step, I will observe that 1, 3, 2, 1, 3, 6, and 10 are my triangular numbers. In this case, if I compare with my numbers of the dice. 6 is the maximum number, so I might stop at this. So, but if you want to continue with knowing these numbers, you will go on here, you will add more 5, first counting numbers, obtain what? The 50 triangular number. So, in this case, my dice, if I'm talking about probability equals to the possible outcomes over the expected outcomes. Now, ask yourself a question. What are the possible outcomes? If I'm talking about the possible outcomes, I'm talking about those possible triangular numbers that must surface at the top if the dice is what? Is tossed. So, since we knew that the dice has got 1, 2, 3, 4, 5, 6 numbers on these surfaces, these 6 surfaces. So, I'm going to pull out triangular numbers among these 6 that will surface, that have that possibility of surfacing at the what? At the surface. So, among those numbers, I'm getting the possible outcomes. So, the possible outcomes, I must get them from these faces. The first face has 1, 2, the second 3, 4, 5, 6, like that. So, these faces, I will have to obtain triangular numbers as I had listed them that side. So, the bracket for triangular numbers that I'm expecting, it must be 1 and 3, then what? 6. So, I will create a bracket for only those triangular numbers that have the possibility of surfacing at the top when the dice is tossed. So I'm having 1, 3, and 6. So how many are these numbers? You count the numbers. I'm having the first number, that is 1 plus 2 and plus 3. So 3 numbers must surface. 3 numbers have the possibility of surfacing at the surface in triangular what? Numbers present in this, on this dice, demarcated on this dice. So, having known the possible outcomes being 3, I'm going to investigate now for expected outcomes. Members, on the dice, I'm not only expecting 1, 2, 3, the triangular numbers, but I'm expecting to throw a dice and either get 4 as the number on the surface, 5 or what? Or 2. So the expected, what I'm expecting the dice to give me either what? Of the 6 numbers. So the expected outcomes are this major bracket, this original what? Bracket, which is having 1, 2, 3, 4, 5, and 6. So if I count these numbers, I'm having 6 of them. So 6 will be our expected outcome. So when I want the probability of these possible outcomes, which are what? Triangular numbers that must appear on the surface. So with the out of what? The expected outcomes, it will be probability will be equal to 3, which is our possible outcome, and 6, which is our expected outcome. So members, you will not stop here for any accuracy as a mathematician. So you have to conclude and say this fraction, it can be reduced, but do not do that in this what? In this situation. So you just divide automatically using the what? Your calculation, the what? In the brains. So this will be a half.